This is the essence of what my organization is. It's the brain, right? Everything here is accurate. I can use this to explain things. The LLMs, these foundational models, don't have that accuracy, don't have that explainability, don't know my organization. Do we expect these foundational models to know every single organization? No, because these things are private. I don't want them to know, but I want to go use them. So that's why this combination of these foundational models, large language models, with your internal brain of organization, which is your knowledge graph, that's what I see where there's a future. And I think what we need to work on is understanding best that integration point between the knowledge graph, the brain of your organization, and these foundational models.
Hello, and welcome to the Cognitive Revolution, where we interview visionary researchers, entrepreneurs, and builders working on the frontier of artificial intelligence. Each week, we'll explore their revolutionary ideas, and together we'll build a picture of how AI technology will transform work, life, and society in the coming years. I'm Nathan Lebenz, joined by my co-host, Erik Torenberg.
Hello, and welcome back to the Cognitive Revolution. Today, we're talking data and how generative AI interacts with enterprise data with my guest, Juan Sequeda, principal scientist and head of the AI lab at Data.world. Data.world, like many established companies that we've featured on the show over time, built much of its platform, products, team, and business before the current generative AI moment, and is now working to make sure that it's taking full advantage of this new technology paradigm for its customers. This is part of an economy-wide trend. Frontier generative AI models are now making their way into all sorts of high-value, often very challenging contexts. From process chemistry labs to novel protein design to U.S. federal courtrooms to the practice of medical diagnosis to enterprise data lakes, GPT-4 demonstrated enough raw power that we now have experts in literally every field working day in and day out to figure out how to make generative AI work for their organizations. Now, it's not all instant success. From Juan's work, for example, it's clear that early benchmarks understate the complexity of real-world enterprise data, and that naive chat-with-your-data type implementations are not up to enterprise challenges. Even the more advanced work that Juan and team are doing with knowledge graphs, while it does deliver major improvement, is still at best a partial solution. So while Data.world, again, like most established technology businesses I've talked to, is not particularly worried about competition from fast-moving AI-first startups, they do see the transformative potential, and they are realizing enough practical utility today that they are rolling up their sleeves and settling into the process of AI implementation and optimization. Interestingly, zooming out, I think this creates the potential for another major phase change in the history of AI. While GPT-4 takes meaningful effort to implement and often still falls short of our dreams, we are nevertheless building foundational capacity for both last-mile distribution and customization, such that the next big model release will have the opportunity to almost immediately plug into many millions of live business processes and systems. The electrification of America took 60 years and included significant public works projects. And all the appliances were designed with a clear understanding of exactly how they'd be supplied with electrical power. Today, in contrast, we live in an internet-mediated, software-enabled world in which updates can quickly be pushed to everyone, everywhere, all at once. Today's software application developers are building somewhat ahead of AI capability, both so that they can deliver frontier features to their users today, and more importantly, so that they're ready to flip the switch when the next big advance comes online. How many months we'll need to wait before GPT 4.5 or GPT-5? I don't know. And it might be just long enough that folks start to wonder whether AI generally is underpowered and overhyped. But my expectation remains very clearly that we will continue to see additional jumps in capability, and that with each future leap, considering the foundation now being laid, the deployment cycles will naturally get shorter and more disruptive. One note for listeners, enterprise data is a complicated space, and we spend some time in the first half of this conversation discussing the general state of enterprise data and data science teams today. If you're already well-versed in enterprise data science, you might find some of this a bit basic and introductory. But for most, I think the additional context will be very useful. If you have any suggestions for how I can better handle the introduction of such advanced topics, where listeners inevitably will have very different levels of prior knowledge, and I do expect this to be more and more common throughout 2024, I would love to hear your suggestions. As always, you can email us at tcr@turpentine.co, or you can DM me on the social media platform of your choice. And of course, we always appreciate it when you share the show with friends, starting in this case with the data scientists in your life. Now, I hope you enjoyed this conversation about generative AI and enterprise data with Juan Sequeda, principal scientist and head of the AI lab at Data.world. Juan Sequeda, principal scientist and head of the AI lab at Data.world. Welcome to the Cognitive Revolution.
Well, thank you so much for having me. Really excited about having this conversation.
Yeah, me too. I have been interested in knowledge graphs recently. I've been kind of feeling for a few different projects that I'm working on that more structured data, something between your kind of classic SQL database and the totally amorphous data that people are just increasingly vectorizing and hoping for the best from, is probably going to be important. And I went on a little quest to see like who's working on this and what's the state of the art, and came across a paper that you had published. So I'm excited to get into that with you, but I thought maybe we should just start with kind of an introduction to you and the company, because I don't know how many listeners will be familiar. You want to just kind of give us a quick intro to Data.world, like, how'd the company get started? Was it an AI company at the beginning? We could take it from there.
Yeah, happy to. So Data.world, we're an enterprise data catalog platform. So data catalog platform is essentially, we're an inventory for all the data and the metadata within your organization. So basically like your library card catalog, right? That's kind of the high level thought about it. Managing metadata has been something kind of since the beginning of just data management, but I would argue that it hasn't really been a focus till the last probably 5-6 years, which became kind of the focus in the enterprise. If I zoom out and we look at what the data management world has been, it's always about moving data, so ETL and ELT, storage and compute of data, so your data warehouses, your data lakes and what stuff, and then you're using your data. You are now trying to your analytics, your dashboards, your ML, and all that stuff, right? And then there's always been this thing on top that we haven't really kind of focused on it, which is the metadata, the data about the data, and that is what data catalogs are focused on being able to kind of understand what's going across all the stuff that's being moved, all the different data sources, tables, and columns that you have, keeping track of all your dashboards and how they're connected across all the different sources, and then also keeping track of your business terminology, your business glossaries, and everything. So that's what a data catalog is. And so Data.world started off in, I think around 2016, so very early on. And the focus was to be, the first phase of the company was to be a GitHub for data. So it is, we wanted to be a catalog for open data sets. And that was the first phase of the company for a couple of years. And we continue to be the world's largest open data catalog. We have over 2 million users. I think like 2/3 of Fortune 500 folks are on Data.world, the open data platform. There's 500,000 data sets. Like during COVID, all the COVID data was housed on Data.world. It was completely open. And it is continuing to be open. And we're actually a public benefit corporation. So that means that in addition to being a C Corp and maximizing shareholder value, we have a public benefit mission, which we're evaluated on. It's to be the world's largest and abundant data resource, advocate for open data and linked data standards, and to be an archive for the world's data. So it's a public benefit mission. And what we did is that also during that first phase of the company, the goal was, from a technology perspective, is create a platform that can scale at a web scale. And that's what we have, over 2 million users. And so we really built a platform that we know that we could have like a high scale and then be able to go share data. So around 2019, the next phase of the company was, hey, we built this whole platform that the open data community is using it within organizations. People want to share their data and find data and so forth. So that's how we entered into the whole, what's now being called a data catalog. People are doing data marketplaces and stuff like that's all where that fits in. So that's kind of the phase of the company we're doing right now. Now, from a technology perspective, from day zero, basically, the entire platform has been architected on top of a knowledge graph architecture. which means that we use, first of all, we're all about open standards. I mean, part of our public benefit corporation. So we use the open web standards of RDF, which is the metadata, the graph standard, OWL, which is for ontologies and schemas, Sparkle, which is for the graph query languages. And that's the architecture we use. So basically everything that we bring into Data.world is already turned into a graph. And why a graph? Remember what I was saying? You start thinking about, I'm moving data, I'm storing data, I'm using data. Like there's all these pieces get connected across kind of all those pipelines. So you just really want to keep track of things and how they're being connected and so forth. And that's a graph. I always say that your first application over a knowledge graph is really the management of all your metadata to understand basically what is that infrastructure that I have within my organization, to understand, hey, there's this data comes from this source and then it gets moved to this thing, it moves to this data warehouse, there's this application, there's people who are using it and so forth. So you're keeping track of all of that. And then now with AI, what happens is that, you need data, right? Data is a foundation of this. So I would argue that we've always been a data company and the data is a bloodline for AI. So the data catalog and being able to manage your metadata, manage your semantics, manage your context, that is critical for the generative AI because that doesn't have the semantics, the context, the knowledge of your organization. It has it out of LLMs, having from whatever it's been trained on, but doesn't have your own internal context. So we've always kind of seen this over the last year and a half when it comes out, with LLMs coming out, for this to be applicable in the organization at a scale where you need accuracy, explainability. Knowledge graphs are critical for that because it provides all that context that the LLMs don't have. And that's what we're seeing, and kind of we've been talking about it. And the paper that you mentioned originally was kind of just the evidence that we wanted to put together to say, yes, knowledge graphs are critical for this, assuming you want accurate answers from your questions.
Let me just ask you to get a little bit more concrete on a couple of things. It's awesome. The 2 million data sets is awesome. The public benefit aspect of that is really cool. I'd love to hear a little bit more about kind of those data sets. Like what are the big attractors? What are people coming to you for? I imagine that, again, like most people probably just don't know. And then I'm also really curious to get a little bit more concrete on, okay, but like what is a knowledge graph? Like how do they typically get created, and like what role does Data.world play in helping enterprise customers do that work?
So one thing is the open data catalog, which is open for folks, right? And then people want the data catalog architecture for there to create their catalog internally. So I see there's usually kind of three main, let's call it applications that that our customers will use Data.world for. One is when it comes to like search and discovery. I don't know what data I have, right? It's a typical problem. Like you have data scientists, we're looking for data and they don't know where to go find stuff. Your data lake is turned into a data swamp type of approach. So they need to have a way to go search and go find that data they have. So that's usually one of the applications around that. So search is something that we're very focused on. And the same way you search things on Google today, and if you search on Google and search for Austin, you get that panel on the side. It says, oh, Austin is the capital of Texas. And here's all these events going on, and here's the weather, and here. Like that is what Google calls a knowledge panel. And that is results that's coming from their graph that they've built. So we do the exact same thing. So if you think about kind of the knowledge graph inside of Data.world that we build automatically when we bring your data, think about it from the concept that show up are, hey, there's a database. A database has tables, right? Tables have columns. There are dashboards, right? There are different types of dashboards. Tableau dashboard, Power BI dashboards. This dashboard was built using data from this table or this query over these tables, right? So you start to see how things get related, connected around that. There's this person who created these dashboard, right? Then there's policies that we were kind of defining. There's PII, there's personal information. This table has PII data, right? So then all these things get connected. So that's kind of the graph that happens underneath. And when we go off and kind of connect and extract the metadata from all these sources, we build that graph automatically for you for all that technical metadata we're seeing. So that's kind of that call it the digital landscape of all your data and that's connected within your organization. So search is one of those applications and over that big graph of your metadata. Another one is around governance. I want to know, again, let's keep track of all the policies around our data, who can use what data for what reasons, who can access this data, right? Where is all the data has sensitive data and so forth. So that's the governance side of things. And then the third one, and we see it a lot, is for data ops, the just operations of data, making sure that, hey, data is getting moved from different places. Again, keeping the moving is like, it's what we call the lineage. Oh, well, this dashboard extracts data from this table comes from this stuff and so forth. So you have kind of that whole graph and lineage of where data is coming from, how it's living. And then you want to make sure that, hey, if I'm going to make a change somewhere, what could that affect? Or if somebody's saying I have an issue in this particular feed of data, where could it be? I can kind of follow that. So that's all the operations of data. And then you can be in your dashboard in Tableau, and then you can actually get notifications from there saying, hey, there was an issue just reported. So just be very careful with the data that's being shown here and it's going to be fixed and so forth. So that's the kind of a third application. So to summarize, data catalogs and our users, they use it kind of for three main things, which is for search and discovery, for data governance, and for data ops. And at the end of the day, all of this is connected, and we build that graph of that metadata all automatically once we kind of have our collectors that bring that on.
Hey, we'll continue our interview in a moment after a word from our sponsors. Real quick, what's the easiest choice you can make? Taking the window instead of the middle seat, outsourcing business tasks that you absolutely hate. What about selling with Shopify? Shopify is the global commerce platform that helps you sell at every stage of your business. Shopify powers 10% of all e-commerce in the US, and Shopify is the global force behind Allbirds, Rothy's, and Brooklinen, and millions of other entrepreneurs of every size across 175 countries. Whether you're selling security systems or marketing memory modules, Shopify helps you sell everywhere, from their all-in-one e-commerce platform to their in-person POS system. Wherever and whatever you're selling, Shopify's got you covered. I've used it in the past at the companies I've founded, and when we launch merch here at Turpentine, Shopify will be our go-to. Shopify helps turn browsers into buyers with the internet's best converting checkout, up to 36% better compared to other leading commerce platforms. And Shopify helps you sell more with less effort thanks to Shopify Magic, your AI-powered all-star. With Shopify Magic, whip up captivating content that converts from blog posts to product descriptions. Generate instant FAQ answers. Pick the perfect email send time. Plus, Shopify Magic is free for every Shopify seller. Businesses that grow, grow with Shopify. Sign up for a $1 per month trial period at shopify.com/cognitive. Go to shopify.com/cognitive now to grow your business, no matter what stage you're in. Shopify.com/cognitive.
I'm really struck by how many of those things seem like they may already be undergoing significant transformation in the AI era. 2016, obviously not pre-AI, but pre-transformer, certainly pre-large language model, certainly, pre any, kind of general conversational interface, with a database. I guess I'd love to hear a little bit more about how you build a knowledge graph automatically in a pre-AI era and how that might be evolving, and then also kind of the kind and the way the data is stored. And I had Anton, who's the CTO at Chroma, one of the high-flying new vector databases, on as a guest on the show not too long ago, and he made this really interesting point that the vast majority of data that goes into their databases has never been in a database before. When you were first building knowledge graphs automatically, how did you approach that? How is that changing? And how is the actual nature of the data beginning to change in light of what AI can now do with it?
First of all, we need to think about, when it comes to knowledge graphs, there is the notion of the schema, of the ontology. Let's go define the semantics, the meaning of a particular domain. So everything I've been talking up to now, when it comes to data cataloging, the domain there is like this technical metadata. Now, just think about the map. Let's draw the bubbles and lines on the whiteboard. You have a table as part of a database. You have a dashboard. A dashboard takes data from a table, right? So that's kind of the schema that we're creating. That's one knowledge graph. We create knowledge graphs about any type of topic. So, for example, let's create a knowledge graph around e-commerce. Well, you have customers. You have orders, right? A customer places an order. An order consists of a set of order lines. An order line can have products, right? And orders are shipped to an address. So you could have a shipping address, you can have a mailing address. So that's basically the schema you start kind of defining. You populate that that data may be coming from so many different types of sources. They can be coming from structured sources, relational databases. Some of that can be coming from unstructured, from text and so forth. They can be coming from feeds that come on JSON feeds or right from APIs or whatever. So the knowledge graphs are a means of integrating data coming from so many different types of sources, and you can model anything that you want around that. Now, what takes time always is what I call the knowledge engineering process. It's understanding what do you mean by what is a customer, right? Understanding what you mean by what is an order or what is an active order or so forth, right? And I think this is the human nature of the problem, because you go ask multiple people and they'll probably have different answers around that. So what is the correct version? What is the correct answer? So I've always argued that if not even humans will agree, how will the machines even know, right? The machines will definitely then be able to generate suggestions. Oh, it could be this, it could be this, it could be this. But at the end, the humans need to go saying, no, our decision is going to be this definition. And that's, by the way, where governance comes in, because you want to have an agreement on what things mean. Because otherwise, then we can, depending on the type of business you are, you can have different types of chaos in there. How things are being kind of slow to create what I'm calling creating these ontologies, be able to understand what this data actually needs. Now, what's interesting with LLMs today, like they're helping, a lot of the experiments we're doing is using LLMs to help us accelerate that process of like, hey, create candidate ways of modeling these things, right? And how about through a chatbot, go talk to the end users to be able to extract the stuff that's in their head to say, how do you define what a customer is? How do you define what an order is? So I think that's something that we're seeing right now for that. So then when it comes to like the vector databases, I think one thing that we're seeing today is the low-hanging fruit of being able to kind of show some really cool AI applications, specifically when it comes to like chatting with your data. It's usually about unstructured. So it's the text, as you mentioned, like the stuff that has never been inside of a database. So it's your documents, your PDF files, right? And in other places you have images and so forth. And that's where you want to that's where vector databases come in, and you have to do all this the chunking and kind of all the bits pieces for the unstructured side. When it comes to structured data, the data that's in your relational databases and your data lakes that come into have thousands of tables, right, and tens of thousands of columns, like that structure has meaning, and it's and that meaning already. A user, a human being will look into that table and they're like, oh, this is what this means. Like you want to add these two columns together, but not these other ones, right? There's knowledge behind that. And I think that's harder to go do based on all what I was talking before. It's like, but what does this mean? You got to go talk to so many people. And that's like not a scalable thing to go do. Again, LLMs today are going to help us because now we can kind of have these chat bots that can help us acquire knowledge. So the low-hanging fruit has been focusing on the unstructured. But I would argue that the untapped potential here is to be able to go focus on the structured data. Because this is the data that goes into your reports, into your dashboard. Like that's the stuff that executives and the boards are looking at those graphs to make decisions around that. And that's the data that's coming from your CRMs or ERP system. Like this is all very structured data. And those types of questions that people are asking, they expect accurate answers, and they expect to explain where those answers come from because they go trust that. Well, if I'm asking questions over text, I'm like, oh, I mean, you have a little bit more freedom over there, right? And then I can point you to this larger document where a human would go in. So I think that's why I'm just like arguing like the low hanging fruit is focusing on unstructured, and there's just so much of it. So we can be very, very busy for a long time and provide a lot of value. But I think where there is tremendous value, one could argue, and I would argue here that probably even a much more higher value is if I can have a chat with my structured SQL data, because that's where your critical decision makings are happening for organization.
What you're describing there, I think, connects to a couple of big themes that I notice across a lot of different areas of AI today. One is just how much knowledge is kind of undocumented. A friend of mine used to call this tribal knowledge. You know, it's the know-how that people share by watching each other do tasks over their shoulder, perhaps, or, on a screen share, perhaps more likely today, or in kind of a quick chat where people ask each other questions. And that knowledge is, because it's kind of not localized anywhere, it is very hard to make that available to anyone. But we're starting to really feel that acutely now in the AI moment, where people are like, well, why aren't these agents working? And often the answer is, because they're kind of very generic and they don't have any of the context, or the sort of, what feels familiar to you is just totally alien to them. So it's interesting that this problem, I guess, has been felt acutely enough in the data world, even before AI, that it's you guys have built a whole platform about it. Could you kind of sketch a little bit more there, typical enterprise customer? I have a little bit of a sense for this. I did a project once. I was a very junior consultant, firm that was working with Washington Mutual, which was once the country's biggest thrift, it was called. And it was in that mortgage crisis moment that I was doing this project. And I do remember just the absolute total gnarliness of the data, and just how many different columns, and there are all these columns derived from other columns, and it was kind of the data swamp situation. I only saw a corner of it in my brief engagement before the bank went, or the thrift went bust. But maybe you could give us a little bit more kind of color on typical enterprise. Where are they today? They have obviously a lot of data, but are we still in a moment where it's spread across tons of systems and people are super siloed and nobody knows where things are? In my case, I remember vividly completing an analysis and then having somebody look at it and be like, this is totally wrong. And me being like, I would have had no way of knowing this. I literally could not, all these suffixes on these columns, they didn't mean anything to me.
This is exactly, yes. And here's the thing, is that the problems that we deal with today are the same problems that people have been describing 10 years ago, 20 years ago, 30 years ago, and more, since the beginning of just modern digital enterprise. Since going into warehouses and so forth, back in the 90s or even before that. So this is my annoyance with the entire world, is can you imagine that the problems that we're complaining about today are literally the same problems people have been complaining about 30 years ago? We're kind of fucked up if we're still trying to solve the same problem. Now, things are getting easier, right? Now the cloud has made things a little bit easier to go do, right? We have self-service to let people to go do more things, but essentially the same problem. The problems are the same. So let's ask ourselves, what have we been doing for the last 30 plus years? And then I'm wait, but now AI is coming. So is this magically going to solve this? No, this is where it's so important to kind of understand our history. So let me go down a couple of examples that kind of I've seen across my careers, right? So at the end of the day, with data, your goal is to go answer some questions. And you want to be able to answer some questions to be able to understand how the business is doing, to make sure that I'm going to make a decision that it's going to help us make more money or save money, right? I think you make money, you save money, you want to mitigate risk. The three main things you want to be able to go to an organization, right? So I have a question I want to go ask. So I asked a question and I need data to be able to answer this question. Where's that data? So in one, call it the spreadsheet approach, you basically go ask somebody who has the data, I need data about X, Y, and Z. And that person will go off and send you a spreadsheet of X, Y, and Z, and then you get it, and then you know Excel pretty well, and you read lookups, or heck, maybe people have an Access database on their laptop, and then they'll be able to go do munging or whatever that stuff. And then they answer their question. There it is. Okay, so that's how we've always been doing things. Is that a scalable approach? Probably not, because then tomorrow I said, I need data about X again, because I need it for the new month. So they said it again, and so forth, right? But I'm asking about X. I'm asking about orders. I'm asking about our latest customers. But when I asked about orders and you heard me and you are going to go do that work, how do we know we're talking about the same thing? Do you have that same interpretation, and you're actually delivering the correct thing that I'm expecting to go do? I don't know. right? But this is how we've been dealing with data for so long. Another approach is what I call the query approach. You're like, look, you're asking me for this spreadsheet of data, and every month you're asking for it. Like, there's no, what I'm going to give you access to the database directly. And you can just query the database. You can connect your dashboard directly to your database. And here's the query that I use. That's it. Like, perfect. Now I can go ask more in real time and do things, right? But you're probably, I mean, depending how SQL savvy you are, you can go edit the queries, you can go add things, and then suddenly this query that was 15 lines long, you join it with something else, and then it's 30, and it's 100, and then, damn, I've seen queries that are 10, 15 pages long. Takes 20 minutes to run, and it runs and executes, and the result of that query is what I'm going to use in my report, present to the CEO. That query has so much knowledge embedded into it. Do we actually know what's happening in there? And we're making $1 billion decisions based on stuff that's into here, right? And then everybody is doing this themselves, right? So if I make a change in my query, how do I know that that's not the change that you should have done too, right? Or somebody else made a change that I should have interpreted too. So that's kind of now the call it the query approach. And then you can go off and say, well, no, we need to have this one standard database or data warehouse where everything is well aligned, and we're all going to go query this thing. And we go off and like, yes, let's go build the data warehouse. But what happens? That takes millions of dollars, and it takes many years to go do. You get requirements, and then suddenly what happens is that you're like, oh, now you can go answer your question on this data warehouse that we've all invested so much time and money in. You go off and you answer that. You now run the question, run your query to answer that question. But what happens? You compare that answer to the way you've been trying to answer that question before. Do you think it's going to be the same? Probably not. So then you're like, wait, I have control of this way. I get one answer, and then I get the answer from this other system, which I don't control. What am I going to trust? You basically trust your process that you control, right? So then this is kind of why you have issues like data warehouses fail. They don't fail for technical reasons. They fail for social reasons because people don't trust them and so forth. And then the problem of that is I'm doing ETLing. I got to structure my data beforehand. And then we went off and we said, no, let's go ELT. Let's go dump our data into a lake. And then the lakes get all messy and they turn swamps. And then so you can imagine, like, this is the story we've been going off over and over again. And a theme throughout all of this is keeping track of what something means. This is the meaning, this is the semantics, this is the knowledge, this is the metadata. And I think what has happened is that throughout the last 30 plus years, we've never focused on keeping track of the meaning, of managing the meaning. And now I'll argue that LLMs and all of this AI is making us realize, oh, if I want to trust that, I need to know what it means. And now my hope, and I'm starting to go see this, is like there is now a new focus on we need to invest in semantics. We need to invest in meaning and knowledge. And that's where knowledge and stuff comes to.
Hey, we'll continue our interview in a moment after a word from our sponsors. If you're a startup founder or executive running a growing business, you know that as you scale, your systems break down and the cracks start to show. If this resonates with you, there are 3 numbers you need to know: 36,000, 25, and 1. 36,000. That's the number of businesses which have upgraded to Netsuite by Oracle. Netsuite is the #1 cloud financial system, streamline accounting, financial management, inventory, HR, and more. 25. Netsuite turns 25 this year. That's 25 years of helping businesses do more with less, close their books in days, not weeks, and drive down costs. 1, because your business is one of a kind, so you get a customized solution for all your KPIs in one efficient system with one source of truth. Manage risk, get reliable forecasts, and improve margins. Everything you need all in one place. Right now, download NetSuite's popular KPI checklist, designed to give you consistently excellent performance, absolutely free, at netsuite.com/cognitive. That's netsuite.com/cognitive to get your own KPI checklist. netsuite.com/cognitive.
Omneky uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omneky so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.
One kind of extra little detour before we get into the paper and how it all works. I mean, obviously, there's a lot of like data professionals these days, and they fall into different kinds of roles. wonder if you could characterize, in rough terms, like, who are the people that you work with? What jobs do they have? What are the activities in those jobs? How much of it, you kind of gave like a sense of like the different approaches, but if you were to actually just observe, do a time study of these folks, how much of their time are they spending on different kinds of activities? Like how much of it is that routine query running and kind of, process that they've done month after month? How much of it is data migrations or, these kind of mega projects that may or may not ever come to fruition? How much is, ad hoc analysis that, where leadership or whoever has, one-off questions that haven't been asked before? I'm probably varies a lot by context, but I have no idea really how people are kind of spending their time. And I always find that to be an interesting foundational question to then ask, like, okay, well, now, which parts of that is AI going to impact? But, for starters, maybe you could just kind of characterize what do they do? What are they doing? I never know what they're doing.
So there's the what I call the data producers and the data consumers. Right. So there's the two types of folks in here. So the data producers are going to be more in the back end, the technical side. They're the ones who are moving the data, migrating the data, or like creating, managing the data, making sure it exists, and so forth. And then you have the consumers. Okay, who are consuming. They're the ones who are searching for data, who want the data, who have a particular task that they want to accomplish. They have a question that they need to go answer. And so those are the two types. So if we let's focus on consumers. So on the consumer side, you can have folks who are going to be your data analysts, right? Or your BI analysts. So people who build the reports and dashboards, right? You have your data scientists, folks who are, or you have your machine learning engineers, right? They're saying, I need to go find this data so I can go do some work to go, again, implement. I create a model, I create a dashboard because I'm trying to go answer a question or making a recommendation or something. So I'm consuming data to be able to accomplish that task. Now, on that side, you hear always like the 80-20 rule. 80% of the time I spend cleaning my data and all that stuff. And that's a problem. And I think actually another annoyance I have is when people say, I have to clean my data. It's data janitorial work. I'm like, no, that's understanding the critical meaning of your data. And you're just like sweeping it under the rug. It's like, that's an annoying piece of like, that is that's the essence of what the meaning of your business is that data. And you're like, I just kind of write some quick code and it's just annoying to go do. Like that's the problem, is that we don't treat it as a first-class citizen. And then on the producer side, so they're the folks who are saying, we got data coming from these sources and we get the requirements. So we hear that you need this data. So we're going to go move the data over here. And now we need it to be more scalable. So we're going to the cloud. So we're going to use Snowflake or Databricks. And I know that you guys, consumers, you want to be able to go run these types of stuff. So we're going to have the data set up in this way so you can go do that. But then they're the ones who are actually putting the data together. How do we know that the requirements that they get are actually being fulfilled correctly? Especially because the requirements from the consumer side, they're connected to the business, how the business thinks. They're talking about customers. They're talking about average order values, right? They're talking about all these metrics. Are the producers, the more technical side of folks, do they understand that? Is it very clear to them, I could present the data this way or that way. How do I know which is the correct way? And I think that's always been a gap, that what I call the producer-consumer gap. And that producer-consumer gap is there's roles that are missing. One of those types of roles is, I'm seeing this evolve now. I'm calling it the knowledge engineer, or also call it the knowledge scientist. And it's really the person or role who can work on both sides of the aisle, right? Hey, I can be a non-technical people person, go understand what you're trying to go do. I can draw the models on the whiteboard. Then I can go talk to the technical folks and say, okay, it's this data for this reason and so forth. So, and we're starting to also see this as called the data product managers, right? You're bringing product management into data and stuff. So I think we have this gap. So there's the producers, the consumers, and I think I'm trying to answer your question, which I can't give you numbers because I don't know these numbers, but I think there's a lot of just repetitiveness happening, right? We're wasting our time a lot. We don't know if this is correct. And a way that we should be able to kind of address that is by having a role which is focused on being that bridge. And it's a role where you're bringing in one of the people, the process side. We're doing product management. It's doing this knowledge acquisition. It's things that people are doing today, but they're not doing it in a first class way. They're just like, oh, that's the second class. That's the annoying thing I have to go do. I'm like, it's annoying to you, but it is critical, and somebody should take the ownership, accountability for that.
Interesting. So that role, if I understand correctly, that would be essentially the power user of the Data.world platform. I'm thinking almost like knowledge librarian, knowledge historian.
So that's a good point. So yeah, it's like a librarian. I would argue that for Data.world, things like Data.world, the data catalogs, you have all three of those, right? So for example, you're bringing in all your different sources. I need to deal with all that technical data stuff that's coming in. You want Data.world to say, hey, I just got this feeds of data, and I just want to know that I'm keeping track of these 400, 500, 600 tables. These other thousands, I'm going to ignore them. So that's where I'm going to keep my inventory of stuff that's going on. We're moving our pipelines of data. All of that gets managed inside of Data.world. So you have that for your data engineers, right? For your technical folks. And then you have your consumers of data who are searching for data, right? Those are the ones who will also come into Data.world, but they're looking at it from a more consumer perspective. Oh, I'm looking for data about customers and about, they can now search for that. They find that data sets. And then kind of what you would want is the data, these kind of people in the middle saying, hey, I want to expose to the consumers this beautiful data product, something that just like your shopping experience in Amazon, right? So if you go to Amazon and you're buying a water bottle, for example, well, there's not only one water bottle, right? There's probably hundreds of water bottles. You go as a consumer, you go in, you search for something, and you're like, oh, these are ranked. I have reviews. I have pictures. There's metadata. There's a lot of descriptions. And which one are you going to go trust? The ones that have great reviews, that has most stars, that has great pictures, that has more metadata, more descriptions. There's other ones that are like, wow, that doesn't have any pictures. I'm not going to trust that, right? So that's the experience of a consumer. Now, somebody had to put all that inside of Amazon, in this case, put inside of Data.world, and that's kind of on the producer side. And they want and how to decide who goes into what. I think that's where this data product management roles are coming in. And at the end, I think you talk about the life cycle of data and stuff. Like, we're spending money to keep this running, keep this data. It's like, you should tell me what is the ROI on this? I'm like, look, we've invested all this stuff. We've created all these data sets. Look at all the people who are coming in to consume this data. I can actually go survey the people and say, if I turn this off, how is this going to affect you? And I should be able to know these types of stuff. And you want to be able to keep track of all these metrics and what's up of how people are using the data and how they're accessing and searching, also inside of your catalog and Data.world. So I think Data.world is something that just connects the entire kind of landscape of data with an organization, from the technical all the way to the consumer and everything in the middle.
That's kind of another angle on one of these big themes that I keep finding in as AI impacts, all sorts of different knowledge work. I have a thesis that the platforms in which people do their work are extremely well positioned to start to kind of create long form narratives of like what people are actually doing. And from that, perhaps begin to train future AI systems on this data, this sort of data. In this case, it's like the data of how we work on data, but in other platforms, it's the data of how we work on other things, right? It could be creative, it could be, you name it, right? Any of a million things. Are you capturing these arcs? Because I could imagine that, in a catalog, you could imagine different modes of interaction where somebody maybe comes and says, oh, I have a question about what does this particular thing mean? They come, they get answered, and then they go somewhere else and execute a query. And so you only see sort of a glimpse of their work process. But I'm sure, you have all these like data connectors and things too. So I wonder how often people are actually like going on a journey within the platform versus kind of blipping in and out of the platform at different parts of their journey.
This is a great observation you're making. And so I think when you look at tools, like in general, the data catalog market, it is very separated from, you manage all the metadata to search and discover and find things. And then I go to another place to go like actually access the data. One of the things that makes Data.world different from the entire market is that we have both of those things. So you can actually search and find the data, then you can actually access the data within Data.world because we have virtualization, federation. I mean, your data continues to stay where it is, right? So you got your data in Snowflake or Databricks or whatever, like your data stays there, but you can actually find it and access it through Data.world. So so we actually have kind of again, that's what I was talking, like we have a full view of everything. Now, you brought up something really interesting, which is something that I'm pushing people to go do, is we need to track and catalog not just all this technical metadata, but it's also keep track of all the questions people are asking, who's asking those questions, what are the answers that they're getting back. The actual, not just, I look for this, I'm looking for this data and here's this data set, go do something with it. Because what we're seeing, we're actually working on at Data.world. It's like, I want to ask a question, show me all the amount of orders that have happened in the Eastern region, right? I should be able to get, here's your numbers by region, by data. Like you get the actual answers to your question coming from Data.world too. So that's kind of where the whole chatting with your data comes from. We're working on this stuff. Now, what happens is that we should be keeping track of the questions and answers because we should govern also. We should keep track of these questions and what is the actual kind of stamped answer for some of these questions that we can. And what happens is that if you're asking for a question, you should be able to say, hey, this other group of people who have been asking very similar questions, and here's the answers that have already kind of been stamped because these are like official things that we have to know for, I don't know, regulatory purposes, whatever. So you should know that type of information. So I think that's something that we're going to start evolving, and then because we'll be able to go learn from patterns that people are having. That's why by the way, all of that just continues to get connected inside of your big graph. So remember, I was like, my original graph was like, you have databases and tables and columns and dashboards. Well, then I can extend that with, I have questions, I have answers, I have people. This person asked this question was executed. This question used an LLM to generate this query that was executed over this database, and here's the answer. And Nathan is the steward who said, this is the official answer for this type of question. And so next time somebody asks a question like that, they can get a very similar suggested question, and they have a governed answer for that. Like, I think that's kind of where we're going, especially for in enterprise scenarios. We're going to have accuracy and explainability. And then obviously you're going to have questions where you're just like, I'm just discovering things, right? I'm trying to be creative around that stuff. And then I think that's kind of also, when it comes to question answering, we should also think about what types of questions. I think it's where a lot of the agents come in. And so if you think about it from a question answering perspective, it's not just give me a question and I can answer to you. It's like, okay, you're asking a question. What type of question is this? Oh, is this a factual question? Is this a subjective question? All right, two different approaches, right? Is this a factual question about the knowledge? Is this a factual question about the data that I have? Do I even have the data to be able to answer this question? Or do you even have access, authorization to be able to get answer to that? Oh, maybe not for all of it, but for this subset you can. So then like the agent should be able to go understand what you're trying to go do, understand your context, where you're coming from, and saying, hey, I can't answer that question, but here's a subset of that question I can't answer, and I can't answer it because of the other reasons. I think that's the type of stuff that we're heading towards. That's what I get really, really excited about AI right now.
Yeah, accuracy and explainability, those are two, it's funny how many, it's not surprising in the sense that, obviously AI systems, AI models are all trained on data, and they're very, they're very much like directly derived from their data. Accuracy and explainability come up in, all the AI systems work that I see. It's interesting that that exact same, framing, clearly predates it in the data management work that kind of underlies now, the AI that's getting built on top. When it comes to accuracy, do we have any good like benchmarks, rules of thumb, reference points for how accurate humans are? This is one thing I find everywhere I go, that people have no idea how accurate the humans are.
I love that you're asking this question, and this is really the how we need to have fierce conversations with each other and push back. So like all the research that we've been doing about the accuracy, and so the first set of critics, what do they say? Oh, but 60% isn't accurate enough. Yeah, of course. I know it's not accurate. So what is accurate enough? 100%, 99%? What is it? Do you actually know? Okay, you got data today to go answer a question that you made millions of dollars, a decision that made $1 million. Do you know how accurate that was? Are you gonna bet your life on the accuracy of that? Go ask that question. I don't think people. I don't know. Do you know? Like you got that dashboard or that spreadsheet from Alice and Bob. Do you know how that work was done? You trust exactly? Really? Do you, dude? People are not asking those questions, right? So they're like, they make the assumption that the machine needs to be accurate at everything, but then they don't even ask. They're not being critical about their own process to go do that. I think this is an opportunity right now to be very critical about kind of how do we evaluate ourselves? Like, how are we doing this? And going back to like how AI is impacting all the tasks that we're doing. It's like, let's go figure out how we're solving that problem today and say, well, wow, this is a very, what is that process? And can we improve that process? And we figure out, oh, wow, there's a big bottleneck, or that's something that is pretty sketchy. It's not working well. And you want to be able to bring in the machines, the AI, to go help for those things. So I think it's really, really important to ask ourselves, how are we solving these problems today? And being honest about it. It's like, oh, crap, I got it. But that's something that may not be doing. I mean, I've done this. I remember once working with a customer who were like years getting this report and making decisions about it. And I went off and go analyzed how they got that report because they hadn't done it. And I'm like, well, do you know that to get this value over here, there's some hard-coded values or like multiplying 0.02 or whatever, like that's happening. And they're like, why is it? And then somebody said, oh, I remember like 2 years ago, we were like doing some special discount, and like, well, guess what? The person who wrote that query hard-coded that discount, whatever, and it's been there for the last 2 years. So all the decisions you've been making has that embedded in there. All your numbers have been wrong for the last 2 years, and you've been made decisions. Now, but the honest OBS here is like, what, the company still made money and stuff. Like, how big of a deal is that? So I think that's also, it's like, how critical are these things? And like, sometimes they're like, that's good enough, right? So I think it's also part of the culture that you have within the organization.
I've experienced, some very similar things. And in a at the company that I started, we did a lot of digital marketing for a while. And, we both like helped our clients do it, and then we did it. And we found just so many instances over time where you come to some initial conclusion and, you really have to challenge yourself. Especially digital marketing will punish you, for being wrong on these things. We really had to challenge ourselves. Is this really right? Does it check out across everything else we know? Does it violate our world model? And, dig in as many layers as we could to finally often find that there was some problem. That happened at the Washington Mutual thing too. I remember one time where, I was summing something and it was like greater than, the limit that it was supposed to be governed by. And it was like, well, what's happening here? Your query must be wrong. And it turned out actually, no, like some other process in the bank had changed some underlying, data, and all of a sudden, everything had kind of, sands had shifted under us. But yeah, broadly, I find that, I don't know. I mean, if I had to guess, I would estimate that like a significant fraction of the data analysis that people are basing business decisions on is just like fundamentally flawed to the point where, they're kind of detached from reality. I don't know if we could get any more, rigorous in our estimation of that, but for me, it has been a recurring theme that just, somebody gives you the result of a query or a spreadsheet or whatever and tells you it's X, and it's like, I do not take that stuff at face value anymore. We were just talking a little bit too about podcast metrics. Oh my God, like we had one. We were looking at the success of the podcast, and it was like, oh, we did really well in this time, and we did really poorly in this time. By comparison, like, look, there's a spike and there's a trough, and it turned out that it was like the way that the month fell with respect to the weeks and the days on which we published the podcast. And, it was like, well, we actually had 9 episodes released in this month and 7 in the next month. And that's why, we got way more downloads in the first month than the next month. It really had nothing, the per episode downloads were the same. But even at that simple of a level, I've seen, people just get like so confused by kind of aggregate measures. Do you have any, this is a little bit of a digression for our core topic, but do you have any tips or sort of habits of mind that you encourage people to, mantras maybe even, that you encourage people to adopt? Like, I always say there's no substitute for reading the raw data. If you have not looked at actual raw records at some point in the process, obviously you can't read all the raw records, but if you have not familiarized yourself with at least some raw records, my guess is there's a pretty good chance you're going to be wrong in the aggregate analysis. Any things like that you preach?
Ask the why, right? Ask why 5 times, right? What is the goal? What is the objective? What is the objective above the objective that you're trying to go do? Because this goes back into like, we have all these ad hoc questions that we're trying to go deal with. I'm like, why are you doing that? How is that valuable for the business? Like, the person, you give that to that person, what are they going to go do with that? And so for me, it's always like, are you tying the work that you're doing to specific business value? And the way to tie that is that you need to know what are the objectives, corporate strategies of the quarter, of the year, whatever, that needs, like, what those are, because you need to be able to push back saying, I'm not going to go spend time on that because that is not related at all to what our quarterly goals are, unless you explain it to me, right? So I think that's something so that's kind of more from where I am going to go and top, right? Get connected it to the business to make sure that we're not wasting time to go do that. Then another approach technique that I do is what I call the iron thread, which is like, look, to how do I know if something is working correctly? Like, don't boil the ocean. That's another mantra. Don't boil the ocean. Right? We love to get it. So start from something very specific, one small thing, and figure out what is the path all the way to the end goal, and do it really, really small. So you have to do it you basically get that one thread through. And then you're like, okay, I understand all the things I need to go through. And then you say, well, let's go do it again. And then you add you're adding another thread to it. And then that thread gets bigger. And then at some point then you're like, well, how about let's do it for another area, something different. And then you can have somebody else in a distributed way, independently go off and do another thread somewhere else. And kind of, okay, now we start getting these kind of threads all straight. I think that's kind of an approach I always do, because otherwise we kind of like get focused too much on the bottom stuff, and then we're not connecting it to the value that people are seeing, because we don't understand. Like, I need to understand what is the not just the output, but what is the outcome that needs to happen. And so you want to be able to kind of just be able to drive all that through from top to bottom, from the executive all the way down to get into the nitty gritty and roll up your sleeves. So all that needs to be connected. But you don't have to boil the ocean, do it for everything. Just do it for one very specific thing, go through it. Then you understand how things flow and what's working, what's not working, where's the struggles, and so forth.
Yeah, interesting. That's software development sometimes can be like that more generally too, where it's a vertical spike through all the layers of the stack to get everything connected, and make one successful round trip is like a good early milestone in a lot of things.
It ties this to AI. It's like, well, that's like all the steps they need to go do, and then you figure out, well, where can I put AI in here to automate things and make it faster, better, more productive?
So perfect transition then to the paper. We've got a lot of preamble before the actual paper that you've published, but high level, it seems like the big demonstration of the paper is that you take GPT-4 and you say, hey, I want you to write some queries for me to answer some questions. And you give it either the pure schema, like the table definitions, and, there's a lot of meaning often implicit there in or to some degree explicit in like the names of the tables and the names of the columns and the way that, database keys and, whatnot relate to each other, right? You can there's an implicit graph, again, somewhat explicit just in the schema structure, and you get a certain level of performance. And then you compare that to, okay, now let's also give GPT-4 a higher level semantic knowledge graph representation of what does this data actually mean. So that, perhaps not surprisingly, given all this preamble, yields quite a bit better results. What additional details about that experimental setup or about the findings do you think are most important for people to understand?
Everybody was excited about chatting with their data. Chatting, also call it a text to SQL, has been an area in computer science that people have been looking into for, again, also probably 30 plus years. So there's been all these techniques happening. And now with LLMs, people are like, wow, this should be much more easier to go create, to do text to SQL. And from an academic standpoint, there's these benchmarks and techniques people have been doing out, and they show 95% accuracy. And I'm like, I'm skeptical about this stuff. And when you look into these benchmarks, they're all very simple. They're like, oh, there's a couple of tables, and and the semantics are very explicit in there. But I'm like, that's really disconnected from the enterprise, because the enterprise doesn't always have that clear, and it's very clear and small. And then the other part is that the questions people were asking were like, oh, here's like a laundry list of questions. And they're like, why these questions? How do you come up with these? So the main research question, so there's two questions. One is, we want to understand to what extent can these large language models kind of generate SQL queries that can be accurate? To what extent that can be done? And then the follow-up question there is, to what extent can that accuracy improve if you actually put the knowledge graph in the middle? And the hypothesis here is that, hey, if you do the knowledge graph, it's going to improve the accuracy. Now, look, we didn't know to what extent. We didn't know how much. And the thing is that just talking to folks, everybody's like, yeah, adding semantics, context, knowledge graph like that should help. But how would we do it, and how much better is it? And like, people didn't know. And I'm like, we were at Snowflake Summit in June, and we were having this conversation with a bunch of product people, and they were the ones who frankly were just challenging us, saying, you guys should just do it with a benchmark around it. And I'm like, yeah. And literally I got on the plane, came back, and I started working on this stuff. So kudos to them for kind of really challenging, pushing us to it. So that was the whole setup. So what we did was that we have an enterprise schema using in the insurance domain. So we're using an open standard called, from OMG, they have a property casualty schema. So this is a representative of an enterprise domain, enterprise schema right there. And then the other thing was the questions we're asking. So you have an enterprise schema, and then we have a set of questions. But these questions, we're actually putting them, we created this quadrant with two kind of spectrums of complexity. One of the spectrum of complexity is on the types of easy questions to harder questions, basically. Easy questions being, give me a list of things. Show me all the claims that are open, right? Those are easy questions. Harder questions are things that are going to be more about strategy, and which involves really questions that I need to do some aggregations. I need to do maths around that stuff. And then from a technical perspective, you also have easier questions and harder questions. Easier meaning I only need a couple of tables to answer this. And a harder question is I need a lot more tables, 8-9 tables to need to be joined. So then you put these two spectrums together, you get this quadrant of like easy questions over easy schema, and then you get harder questions over easy schema and so forth. You get all these different quadrants. So that gave us a perspective of understanding the types of questions that people can ask. And then the third thing that we looked into was let's invest in coming up with the semantics, invest in creating the context. And that's what we call the context layer. So here is the ontology semantic layer, and here's how these things map. So very simple. There is a claim, has a claim number. Oh, there is a table called claim. Okay, perfect. That matches. But there's actually, that table has, 15, 20 columns. One column is called claim identifier. That is not the claim number. There's a column called the company claim number. That is the column that has the claim number, right? So they make these mappings. And then you would have things like values. You'd like, well, I want to know what are my policy holders. Well, it's everything that has the role column equals PH. Agents, where role equals AG, right? That's the semantics, like that. That's the context that you have in there. So we made that very explicit. So that's what we come up with, kind of as an input, kind of into the benchmark. And what we did was evaluate, saying, very simple setup. on purpose wanted to do very simple because I wanted to like get the bare minimum, the simplest prompt that you can imagine. Here is a SQL DDL schema. You copy and paste the SQL DDL and you say, write a SQL query for the following question. And then for the knowledge graph, we said, here is the OWL ontology. The ontology, that's a semantic layer, which is an open standard that we gave it, right? We've understood that GPT-4 knows these open standards. And you copy and paste and we said, write this Sparkle query for this question. And Sparkle is the open standard for knowledge graphs for the queries. And we just, so also the caveat is that we put the schemas and the ontology, the semantic layer, as part of the prompt, right? So it has to fit within the amount of tokens. And you just give that to GPT-4 and it generated the query. And then when we started comparing all the queries that were generated, I think that we get that 3x differentiator. So there's 3 times more accurate queries if you're doing the knowledge graph versus if you only do SQL. That's if you compare all the questions. And if you look them inside of the quadrants, effectively, when you had questions that required high complex, the tables, basically questions that require joining more than 4 tables, SQL query that was generated by GPT-4 would always fail. And I think that was an interesting point. It's like, oh, so if you have queries that require more than 4 tables, like that's not going to work very well. So, and that was for this very simple prompt. I think work that we're doing right now is, well, we're going to go test it with other models too. And I think what we want and what the community to go do too, and we're seeing this is like, well, yeah, let's go improve the prompting. Let's go figure out more context. Is there a way I can pass the context to SQL in some other ways? Like, this is where we need to start working as a community to go figure out. We presented an initial baseline. So going back to our original research question is, to what extent? We found an extent. We know this. And now this is how we advance science, is like, let's get other people build on that work and let's see if we can improve the extent.
It definitely is, again, another major theme, just how many of the benchmarks that largely have come out of academia over the last, 10 years have just been kind of blown away by the latest models. I think that's one of the really interesting indicators of just not only how fast things are moving, but how fast they're moving relative to people's expectations, is that, you see like 2019, 2020, even some 2021 benchmarks that are just like obsolete because they're totally broken by the latest language models. And they were built in the way that they were because, the people didn't even, couldn't even really conceive of at the time that an AI would get good enough to like solve all this. It was like, well, gee, if it solved all this, we'd have AGI. Turns out there's a little bit more room between solving these benchmarks and AGI at least. So now you've got this kind of first stake in the ground, basically, right? Okay, all these old simple schema benchmarks are increasingly obsolete. Now we got to increase the challenge. Let's bring a real like enterprise grade challenging problem to the models here and see how they do. They don't do so well. Here's one initial technique of layering on semantics that makes a huge difference. And of course, we're fully expecting that people are going to, continue to improve on those techniques and get better and better performance. Do you have any tips for, how people, and especially for enterprises that want to like do this for themselves for actual like practical purposes internally, what sort of guidance would you give them on constructing their own internal benchmarks or, eval suites?
The contribution of our work, one is it is not just the results of the benchmark, but it's the benchmark framework itself. So what I'm telling everybody, and actually working with our own customers doing this too, because they're like, we're working together to build these chat systems, these agent systems and stuff. And they want to evaluate how good this is. So one, they have their data, right? So they got that. So first check. Number 2 is on the questions. So I think this is really important to understand what are the questions people are asking. And goes back to what we were talking earlier before. It's like we should catalog and keep track of the questions, right? So what are the questions people are asking today? Who's asking them? Why are they asking them, right? And how are they solving those answers? How are they getting those answers today? Are they getting those answers today through a spreadsheet that somebody gives it to them? Or do they write a query? Do they get it through a dashboard? Like, let's figure that out today. So then what happens is that get those questions, let's then put them into those quadrants, right? Is this an easy question? Is this a harder question? Right? Is this a question that is just a list of things versus this is a question that actually involves aggregating all that stuff? And this is a question that requires small amount of tables or large amount. So start putting that into those quadrants. So that is my main recommendation for folks. And then in order to avoid boiling the ocean, make sure that you're focusing the questions that are actually going to provide some value, right? And that's why it's important who's asking those questions and why they're asking those questions. So I think that's a very important thing. And then the third one is the context. And I think the whole point of the work that we were presenting is that you should invest in the context. You need to invest in the semantics of what the stuff means, because frankly, that's what the LLMs don't have. So you need to start investing in that. So that's where at least our customers, they're already investing in the context because they already have Data.world. So, but for other customers who are like thinking about this, I'm like, well, if you want to have a chat with your data on your relational SQL databases, and if you don't have a catalog, you got to solve that. You got to go bring in a catalog, but the catalog is for the sake of understanding, keeping track of all that metadata to start building that semantic layer and everything. And then don't boil the ocean. That's where I would say then that have that iron thread approach and tie it. Go bring in the data you need to go answer those questions, and then keep track of all that metadata. Treat the semantics as a first-class citizen. So again, just summarize: one, you already have your data, so great, check. Second, make a list of all the questions, put them into quadrants, and figure out and prioritize them by the why behind them, and then understand how they're answering those questions today. And third, if you don't have a catalog, then that's where you need to start from that technology perspective.
So what do you think the prospects are for this kind of chat with your data paradigm, right? The dream would be like the AIs get really good, and the decision makers, whether it's the middle of the night when they have their brainstorm, or, whenever they can. I mean, AI has a lot of advantages, right? It's like always instantly available. It, you can kind of pick up where you left off. I also recite these. Here are the big challenges, presumably accuracy. It seems like we're probably not there yet. You said kind of 60%. It's not good enough. I would assume that, yeah, probably not. Do you have a sense for like what is good enough and sort of what the steps are likely to be to get there?
For in the benchmark, it was like 60% for all the questions, right? Now, what we really need to start thinking about is, given a question, I need to analyze, can I even answer this question? And I think the thing, this is what we're working on right now, is saying, hey, give me questions. I know that I can answer this question. I know, or give some confidence measure that if I can answer the question or not. So then what you're going to do is reject the questions that you can't answer. And then you're going to focus on answering the questions that you can answer. And I highly suspect, and this is something our research has shown us, that from there we can get to the 90% of that stuff. So if I zoom out and I imagine the user going into your chat, you ask a question, you'll either get an answer with an explanation, and I'll dive into a second, or an explanation saying, I'm not going to answer this question for the following reason. That already gives you confidence around that. Now, when it goes into when I do know that I can go answer a question, what happens is, and this is where the knowledge graphs come in, and it's tied to accuracy and explainability. If I ask a question, I can extract, using the LLMs, the concepts, all the things that are being asked in that question, and I can look them up in the graph. And if all the things that I'm asking show up in the graph, show up in the knowledge graph, I'm like, oh, I know about all these things. I can then formulate a query. But if I'm asking for a question and I'm like, oh, I can't find this in the graph, I'm like, I don't know. So basically, you know what you know, and you know what you don't know. So then that's how I can explain that I don't know this, therefore I'm not going to go answer that question. And then if I do know, I can then create the question, and then I can answer it, execute it. And here's a big distinction, is that LLMs are not answering the question. Because if the LLM is answering a question, you're training an LLM, then it's always going to be probabilistic. Like, it can't be for certain, I can't have certainty behind it. LLMs are going to be an assistant to create the code that is going to be executed over the system that's answering the question. And when it's code, that is something I can reason upon. That is something I can govern. That is something I can manage. And it's something I can use for an explanation. So if I match it to the graph, I'm like, okay, here it is. I generate this query. This is a query over the graph. And then this is where all the technical metadata catalog comes in, saying, oh, this exists in the graph for this reason. It comes from this part. It goes to this table, and this person was involved in the creation of this. It was authorized by this. That's why you're getting that information. So I can then not only give you the answer, I can give you an explanation, and I can go as deep and granular and nitty gritty and technical that I want, or I can give it high level. So I think also one of the things that we're working on is to another kind of a little bit of an annoyance I have is when we talk about explanations to whom, right? You're giving a non-technical person an explanation. They probably just want an explanation in English and also know who they should go talk to if they have a question, right? Don't give them code. They're not going to understand it. If you're giving an explanation to a technical person, they probably want to see the code, right? If you give them just a high level of fluffy, they're like, they're going to call BS on that, right? So you also need to understand who are the personas you're giving explanations to. And again, the graph is just basically, I can traverse the graph as much as I can to get as deep as the level of granularity that I need. So I think that's why knowledge graphs are critical for the accuracy and for the explainability.
So I'm kind of mapping, a bunch of familiar AI application building techniques onto this problem. And one is decomposition. It sounds like, you could imagine just taking the semantic layer and the schema and dumping that all into context and saying, hey, have at it. Or you could imagine kind of breaking that up and saying, okay, first thing, your first job is to just look at the semantic layer and determine if you have the information to answer the question. Then you could have a peek at the schema and actually generate the query. That decomposition, takes more work. It definitely kind of makes things a little bit more brittle depending on, how quick your system is to change or whatever, but it really can drive accuracy. I imagine that's a part of it. Fine-tuning models, obviously also a big trend. GPT-4 fine-tuning is like in, limited release. I don't know if you've had a chance to fine-tune that or if you've had experience fine-tuning other models to get better at this, but that seems like another opportunity for improvement. And then you mentioned earlier too, like established questions and kind of canonical ways to answer them. I think they're of like these sort of skill database type paradigms, like the Eureka paper or the Voyager paper out of NVIDIA, where, when they find something that works, it's like, okay, cache that basically to a database. And next time we get a similar question, or a similar challenge, and, in their case it was like Minecraft type of skill building, but here it's obviously database type of work. Let's see if we've done this before, and have kind of an established answer. I imagine all three of those are kind of directions you are pushing on.
Yeah, right. The answer is always it's hybrid. It depends, right? So yeah, for sure. So I think from the science perspective, I start with one thing to go see how well that stuff is, and this one is like, let's start with the more bare minimum prompt engineering to go do things, and then you have other tools that you want to kind of figure out, like what can I use for vector databases that I can as another tool there. It's like, also note that for the first experiment, like everything fit in the context window, right? So maybe I have my ontology, my semantic is going to be so big that I can't always pass it in here. So I need to be able to kind of get parts of it out.
Were you working with the 8K version in this work or the 32?
The 8K, yeah, because the ontology wasn't that big anyways. And then when it comes to fine tuning, I think there's two things to look into. One is, are you fine tuning with the data or fine tuning with the metadata? And I will think that fine-tuning with the data is probably not going to be valuable because, first of all, you got millions and billions of rows in my Snowflake or Databricks, my data lakehouse. Are you really going to extract that and put that in there? It's so expensive, and then which gets updated all the time. Like that. And then, by the way, then in that case, your LLM is trying to go answer the question, but then it's going to be probabilistic and it's not deterministic. And you like, if you're going to go ask something and it's going to get your balance for your bank account, better be freaking accurate all the time, right? So like there's particular scenarios where the accuracy is critical. So, but when it comes to like fine tuning on the metadata, I think that's going to be like huge opportunities. And as you said, it's like, oh, here are these patterns of questions. Here are these types of questions, and it fits these patterns of queries. Like that's the stuff where you want to go fine tune on that metadata there, because then it should have like, I know you're going to generate the right increase the possibility to generate the right query. Now, other thing is when you generate a query, you're generating a code, and I can reason upon that, and I can do that in a deterministic manner, right? Now I can actually check, I can do static analysis, and I can check if this is the correct, if the code is going to be correct or not, with a bunch of heuristics. So then I think there's another set of kind of techniques that you can go use. It's a post-processing. So it's prompt engineering, you're going to do vector databases, you're going to do fine-tuning on the metadata, not on the data, on the metadata. You'll do some post-processing. So these are all basically just a bunch of tools that you'll have. And what we'll see is like an agent framework that will, for each kind of state in that agent, will use this tool. For this data, we'll use this tool. For this tool, it just has a lot of tools at its disposal. And I'd argue that a lot of the IP that will come out is on how people are structuring their agent frameworks, and how at the end of the day, you want to have an intelligent agent who can really understand its environment, perceive its environment, make decisions autonomously based on their environment. And that's really going to be how sophisticated your agent framework, your state model is going to be. The current kind of RAG architecture that we all talk about, I think that's the simplest, most naive type of agent system. Like, right, you get a question, you send something you set up to the vector database, which then get context back, and you send the LLM. Like, that's kind of one-stop shop for everything. That's going to get it broken down into so many different pieces, and that's how we're going to start developing kind of these agents. Which, by the way, this agent stuff is another thing I'm calling out there is we've been working on agents. This is the good old-fashioned AI. People are working on this stuff for like 50 plus years. There's so much work on agents, on planning. So hopefully we don't spend time reinventing the wheel and build on the shoulders of giants so we can advance very quickly here.
Yeah, one thing, a tidbit that I've found, and then I have a project I want to ask for your advice on, is when fine-tuning, this is definitely proven true for GPT 3.5, unclear, everything has to be kind of revalidated when you move up an order of magnitude in scale. So I'm not sure yet how this will apply to GPT-4 fine-tuning, but for 3.5 at least, fine-tuning on chain of thought type data has proven extremely valuable for me in terms of getting the fine-tuned model to behave how I want it to behave. It has not been good at learning facts that way. So certainly I wouldn't fine-tune on like raw data. Even fine-tuning on like the definitions of tables and stuff, I wouldn't expect that to work very well either. You might do it, but you're still going to need it in context to be like accurate from my experience. But where I've seen the most boost is in kind of explaining the way in which we want you to go about going through this problem. And having a fine-tuned, and it doesn't have to be huge, again, in my experience, as few as like 100 examples can get you a huge boost at the 3.5 level. But it's just really critical to have that kind of explicit step-by-step that the model, because obviously we know that like chain of thought, think step-by-step is really helpful. But you have to kind of demonstrate what kind of, chain of thought do you want or do you need, to solve the problems in the particular context. So here's my challenge. And this is really why I kind of got down this rabbit hole of knowledge graphs a little bit in the first place. So I'm working with this company, Athena. We're in the executive assistant space, and we are trying to deploy AI in a million, different ways to enhance our service. One of the things that we know that our clients would really like is if we had some way for the EAs to have like always on access to everything about them, right? All their preferences, all their history, whatever, anything in the background, right? A lot of times right now, the EAs have to ask questions, and it would be better if we could somehow, answer those questions without them having to ask. So the idea is like, can we create a long-lived client profile that we can sort of maintain and update over time? A huge challenge, though, is almost all the data is unstructured. We like interview clients when they come on board and, record that call and transcribe that call and then summarize that call, but it's all text. The whole thing is text. There's no schema whatsoever. So we can then throw that stuff in a vector database and query against it and get, kind of what did they answer at the time of the onboarding call. But then, of course, things change, right? So how do we add more to that database over time? And how do we sort of manage like what supersedes what? And I wonder, this is pretty early stuff. I think we're like, I don't know if we're on the absolute edge of tackling these problems, but there's not too much work out there on this kind of thing yet. But I wonder if you have any kind of thoughts or intuitions for us as we think about something where the core challenge here is there is no schema. It's all just text. And we're trying to sort of be able to like dump new stuff in there, but then have it maintained in a way where we get the right information, at any given point in time. And we don't have great solutions for this yet. So any pointers or suggestions would be valuable.
I will argue that there's always a schema. There's always an ontology, there's always semantics, and it's implicit because you're talking about the same concepts over and over again. You're maybe using different words that mean the same thing. So an idea here is like take all those all that text that you have, all that unstructured stuff, and just ask GPT to say, generate an ontology or a taxonomy or a business glossary from these things, right? And then you start identifying what these concepts are. And I think for your particular space, right, like think about the domain, model the domain, like what do people do? Like what are the roles involved? What are the tasks? Like those stuff are probably, you're going to have really generic ones that are going to go. They're going to be specific. They're going to be generic across all types of companies, and then I'm sure there are going to be things that are very specific. But then kind of figure out what are the high level ones that are generic. It's there. I mean, you said there's no schema. There is a schema, right? There's a meaning behind everything we're talking about. So just to kind of automate it, just go get all that text and just say literally the prompt. And I do this all the time, like generate a business glossary or generate a semantic layer, generate an ontology based on the following texts or questions. It's going to come up with a bunch of stuff, and then you're like, oh yeah, that thing is related to this thing and that, and then now you have like a consistent control vocabulary way, and that's something that you can use later on in your chain of thought, right? Or just even how you're presenting things in the user interface, or how people are just chatting or conversing with it. I think in a way, this is anecdotal, but I kind of, when we set up these, when we created these semantic layers ontologies, what I've seen is that people start changing their behavior a little bit and using the words that were defined inside of that ontology, inside of that semantic layer. And then it's a human behavioral thing. It's like, oh, well, if I use these words, I actually get my answers, right? So then they start changing. And then actually, as an organization, we all start using a common vocabulary. We have that lingua franca. And it's like, at the end of the day, like, yeah, we should. It would be great if we started to agree on things. And I think this is also a way to kind of get that, have that human behavior. So anyways, long story short, there is a schema in there. Use GPT to help you extract what that schema can look like based on all the text that you have, and then reuse that in just any other techniques that you're doing.
Yeah, interesting. So would you recommend, right now we are kind of just chunking and dumping stuff into vector database and kind of querying against that. We're using the hide technique, the hypothetical document embeddings, which is, basically the translation when a user comes to our chat and says, what is X about the client? We translate that to something that we think is like what the answer is likely to look like. And that's the hypothetical document embeddings. I'm sure you're familiar. And then that seems to improve our the accuracy of our retrieval. But we're purely using this like vector database. We're not really using much structured data. Do you have a recommendation for like what database would you recommend? Should we go with like a Postgres with their vector thing, or should we be thinking like graph database? Because we do have a lot of, I think a lot about that AI town paper. I don't know if you saw that one, but it was it made the rounds. It was like these little AI agents were running around and like making plans and interacting with each other. For me, one of the most interesting aspects of that paper was the way they handled memory was through a periodic sweep of all these raw observational memories into these kind of higher level synthetic, like thematic, or kind of more episodic memories. They would, the agents would write down, I talked to Juan at this time, we said this and this. But then, there's too much there, pretty quickly for the, especially with limited context, that's of course, expanding. But to manage that, they had to kind of synthesize it into this like summarized layer. And I thought that was really interesting. We haven't implemented anything quite like that. That would seem like a very natural thing, perhaps for a graph database of like, this was like synthesized from this, or, these, if I'm looking at some like abstracted, summarized memory or, description, like what are the raw observations that came from? Where do you think I should put that data?
I think this is going to be a combination of using whatever vector database, vector similar indices, whatever, and then I think some sort of graphs. I think this is my perception is that's where things are going to head. And then, I mean, at the end, just use whatever graph database you want, and things can change. I mean, I'm not a big proponent of like use this database or whatever. You're going to have virtual knowledge graphs for things where you have all your enterprise data. Like, you're not going to move all your data from Snowflake or Databricks into a graph database and keep copies of that. No way, that's not going to happen. You're going to have a virtualization layer. So you can query it as a graph and it gets translated to SQL over that. I mean, that's exactly what we did for our benchmark work. So that's something if you already have existing data in a relational database or your data lake, you're gonna have a virtualization, knowledge graph virtualization layer. But if you're starting from scratch, then I think you're gonna have a combination of those two. Guess what's gonna happen? Every single structured database is going to have vector features. If they didn't have it yesterday, they had it today. If they have it today, they have it tomorrow. So all graph databases are having this right now. So much all the SQL databases are going to do that today. Are vector databases going to have SQL interfaces and graph interfaces tomorrow? Yeah. I've been explicit about this. Vectors databases, that's a feature, not a category. There will only be one winner. Whatever vector database is, there's only one winner. Everything else, it's just going to be, I'm just going to use this other database that's going to have a vector feature, and it's going to be enough. That's what's going to happen the next year or so. And you will use that. You will need to use the vector database if you have a real scale issue, like a scale need. Otherwise, all databases will be adding vector features. So,
well, folks can juxtapose that against Anton's answer in an earlier episode. His big thing, which I did think was compelling, he basically said the data that comes into Chroma has never been in a database before, and he was basically like, just the overall growth of how much data is going to go into databases is headed for like 10x because of just all the unstructured stuff moving into these new structures. And so like everyone can win, because the whole market is growing 10x.
But my whole point is that you look at the Snowflakes and the Databricks and the Azures of the world who have already all the SQL stuff. They're going to say, well, we should be able to go support more unstructured, and they will. And they will do that. Now, these vector databases, they're like, oh, we do that too. But they're like, oh, but you don't offer SQL. So what? They're going to now reinvent SQL, add SQL to that stuff? No, they're not. And then it's now for scenarios where you need best scalability and all that stuff for vectors, then you will want that. But that market is not going to be that big. There's going to be one big player, and everybody else is going to be behind. I mean, it's like MongoDB, right? MongoDB is the winner, and there are other kind of NoSQL databases. They're all small behind. Where's one winner there? It's MongoDB, period, right? Go look at their stock. So, yeah, I think it's what's happening.
So what other uses for AI in data are you most excited about? I'm thinking about things like, as a application developer, I find it still pretty tough in a lot of cases to figure out like what are people doing as they go through my application. It's easy to like log stuff, log clicks and log whatever, but to really synthesize that into a story, a lot of kind of products try to do that, and it's been a big struggle in my experience to get them to work well. But I feel like maybe AI can kind of come along and narrativize. I also think about things like anomaly detection or sort of determining like what's relevant or not relevant when it's not obvious by definition. But I'm very curious to hear like, aside from this kind of chat with your data question answering use case, what other roles do you see AI playing in the data world in the near future?
Suggest descriptions about things. People have to go write these descriptions, and they're like, well, at least I don't start from a blank slate anymore, right? So, and that's just applicable. I mean, I write an email about something, right? I just use it and don't have to start from scratch, right? So I think that you're applying that for that type of metadata. Just like any type of documentation, that's a big lift on that thing. You can also use it, like, here's another one. I mean, talking about anomaly detection or PII, like just pass the schema to GPT and say, out of this schema, which columns do you think may have PII data, personal information, right? Or it will give you some things of like, hey, those are actually pretty good candidates. And guess what? You don't have to look at the data at all, right? And that's probably, that's something already, it's a big lift around that stuff, right? So a lot of the documentations and kind of this augmentation of metadata, I think that's one thing. Second, for search, just in general, I think just more natural language search, that's going to be another one. Again, that's a productivity lift, right? One that I found really exciting is on like explanations, right? So it explains code pretty well, which is another type of documentation. So a lot of this documentation you do. And one that I find this really interesting working with one of our customers, WPP, who's the world's largest ad agency, is they wanted ideations. So I want to kind of use the LLMs as a way to inspire me. So basically it's like Data.world, you are a catalog of all our data. You know our data sets. Tell me what are the questions that I could be asking with the data I have. And then it's like, oh, so I start generating candidate kind of questions. Then you could be asking this question and so forth. And then people are like, oh, that's interesting. I didn't think I thought about that. And you can keep track of all these questions and start connecting them. And then we've been doing these things like, oh, I have this problem I want to go solve. What data do you recommend me to go use around that? So it's like, well, you can give all this context. Here's all the context data you have. Here are the problem. GPT, come up with some interesting solutions and then make suggestions of what they can do. So it's about ideation, but I think that's, again, more of the productivity lift. So those are things that we're seeing here. Another one is around this knowledge acquisition. It's like, let's go talk to people. Wait, so what do you mean? When you mean customer here, what do you mean by active customer? Like right now we have to have those conversations. Well, human to human, like what? And now I can kind of automate and scale that out, saying, hey, can you please spend a couple of minutes chatting with my bot here? You're going to ask me questions. And we've done this, set up our own GPTs and like, be a psychologist, be very Socratic and ask somebody, what are the questions that they're trying to go, what questions do they need to go ask to the data? And why is that important? They keep going in, why, and try to extract the knowledge. And then in one day, I could talk to 20, 30 different people. And then I could use GPT again to summarize all these discussions saying, hey, look, when we talk about active customers, here are all these different definitions of what they could be, all right? So that's really helping me, again, in the productivity way, faster understand what we mean by things. And that's the one I'm most excited about. And I hope people get excited about that too, because that's the one that has always been that bottleneck. The knowledge, acquiring knowledge from people's head has always been a bottleneck because you got to go talk to somebody. Now we actually can do that at scale with this. And that means that we can learn so much about how the business operates, map out business operations. And we want to have operational excellence and understand basically all our business processes and like, how can we improve these things? Like, well, we don't even know what our business processes are. Well, I can go interview somebody and say, how do you do your job? And I can map that out and say, wow, look at all these manual steps that happen for this stuff. Like, that's a bottleneck. We need to go improve that so we can improve our operations.
How far do you think this goes in terms of productivity lift in the short term? Meaning like, let's just say we have the technology we have and we apply it well. Are we talking like a multiple X increase in productivity? Certainly, I personally feel that in the coding use case. And what does that ultimately mean for data analysis? Like, do we end up, the old bank teller thing is sort of the happy story where, we introduced ATMs and then, people said, oh, that's the end of the bank teller, but it's not. There's been a lot more bank branches open. Classic example. Is that where we're headed in data work as well?
In all work, everywhere. I mean, I think we on our podcast yesterday we had Jeremiah Aoyang, and we were discussing this. Like, okay, who is not going to be affected in data? I mean, we came to the conclusion that only somebody who literally lives in the middle of nowhere and doesn't talk to who doesn't depend on anybody else, because you're part of some supply chain, and that supply chain is going to get affected by AI. So I think everybody is going to get affected by AI, going to be more productive and stuff. And then there's just the honest, no BS here is that, yes, we have to deal with the job change that's going to happen. There's going to be less jobs, and we're probably going to have to figure out UBI. And what we were kind of just talking about is this is probably going to be on the top of a presidential campaigns in 8 years from now. Like 8 years from now, this is going to be a deal that this is going to be top of the conversation when we're electing president. There's going to be premiums for dealing with humans, right? Because at the end, everything's going to be so much automated. We're doing, we're playing around with Perplexity yesterday, like we're doing our podcast or Pi AI, and like this stuff is replacing a lot of the humans. I mean, a lot of stuff that humans are doing. So what we'll see is I will pay a premium knowing that I'm going to interact with a human and not with an AI. So I think everything is going to get touched little by little. Another thing I say publicly, and hopefully people will take this the wrong way, is like I feel bad people who are doing coding boot camps, because that's just going to be completely commoditized. I mean, writing code is going to be all fully automated. What we're going to need are people, are true algorithmicists, computer scientists, people who are thinking about solving the problem, because you're going to come up with the algorithm, the step-by-step to solve a problem, and the implementation, because you're going to break down the problem into smaller pieces, then the implementation, the code for that is going to be the product, and it's going to be 80-90% correct, right? So knowing how to code, but without knowing how to think about problem solving like that. So I think all these jobs are going to go, a lot of them are going to go away. I mean, we've seen this again over a generation. I mean, when the typewriter came out, people were against it because it's like, oh, if I write it by pen, I know who wrote it. I can see their handwriting. And like, no, this is offensive because I don't know that people are going to be typing these things that we don't know who's going to say these things. That was the argument back at the beginning. Yeah, well, I don't think that's an argument anymore. So all these arguments will come in, and then we'll go. And I think it's going to move so fast that we're going to see so many changes in our generation.
So how would you anticipate that playing out for like an enterprise data team? If obviously, it can be generic, but like, let's say you're a big enterprise and you've got all these systems and you've got however many people. I don't even really have an intuition, for like what's a typical enterprise data team size and what are the role breakdowns. But how would you expect that to evolve in terms of like headcount, which roles, kind of change or go away? How much are people then also spending on AI? Like, are they saving, an order of magnitude on their costs, or is it, does the AI end up being expensive? What's the before and after picture as this transformation happens?
The roles that are going to be, they're going to stick around or are going to be created are the ones that are very people heavy, are the ones that are going to, where you need a lot of thought, right? So it's like doing analysis. I mean, think about like a data analyst. It's like, I mean, if you're doing just the generic analyst that like reporting on metrics that are all very well known in a particular industry, like that's going to go away because these large language models, all these AI systems will know, I mean, all the foundational metrics in every single industry, like that's done, right? So, but then it's like people are going to be the creative thinkers, and they're like, well, what about this that nobody's thought about? Like, not even the AI is able to come up with this. I'm going to use the AI to come like, so people are really, really critical thinkers people who can connect the dots from like so many different places. Like, oh, look, this is probably something we should go figure out. Like, I think that those are the types of roles that will really, really go value. And then you can see that in the analysis of the data, and coming up. And the other one that I'm very focused on is on managing the knowledge of your business, right? That's going to get managed but being able to keep track of that, understand. The LLMs, the AI agents are going to assist me in kind of collecting all that knowledge, but really then figuring out, okay, we're going to decide that an active customer means this for these reasons, right? Like, there's going to be people behind all that stuff. So I think when it's all about critical thinking, those are the roles. And then other than that, I think a lot of that stuff is going to get pretty commoditized. You
kind of alluded to creativity, insight, eureka moments, if you will, being one of the things that the AIs don't clearly deliver that we rely on humans for. I very much focus on that as well, because it seems like that is I think about AI a lot in terms of just threshold effects. Like when AIs can do something, we can suddenly be in a very different regime from as long as they can't. And having these like insight, kind of breakthrough eureka moments, it feels like a huge threshold that we have not yet passed, certainly not with any reliability. I would say it's like very rare.
This is on my to read list. I've seen a couple of papers and I was like, whoa, this scientific discovery only happened because we use AI. I'm like, that is freaking amazing if that's actually happening, because that means that we're actually going to advance science, taking unknowns and making them knowns. Like, this is freaking amazing that this happens. But it didn't do it by itself, right?
A lot of scaffolding. Yeah, a lot of kind of framework around them is definitely still necessary. But yes, I think we're just starting to scrape at the bottom of that threshold right now. With DeepMind recently had an interesting one where they advanced the state of the art in some challenging math problems. So it's funny. It's like, I don't even really understand the problems, and they're, and the AI is advancing the state of the art. Fun search. Yeah. I think of Eureka, which is an actual name of a paper out of NVIDIA where they used GPT-4 to write reward functions for reinforcement learning for robot control of like a robot hand. Gabe Gomez, who did the autonomous chemical reaction optimization with GPT-4. So we're starting to see these, like, you might call it sparks of AGI if you're so inclined. What else, though, aside Eureka moments is that's a huge one. Is there anything else that you would say, if I'm a OpenAI or a Google DeepMind or an Anthropic, and I'm like, where are they falling short? What are the kind of persistent weaknesses that you would love to see us address? Do you have a thought on that?
These foundational models don't know anything about my organization. These foundational models, these large language models, have as a large language model, they're experts on language. They know general knowledge, right? They don't know anything about my organization because they've never looked at it, they've never trained on it. The context brain of my organization, and that brain is the knowledge graph. Now, the thing about the knowledge graph is that it's not a language thing, right? It's not like I can't do natural language part of the knowledge, but this knows everything about my organization because I keep track of it, I govern it, and I use AI to govern it. I use AI to create it, but like there is this thing that I have, and this is my precious. This is the essence of what my organization is. It's the brain, right? And everything here is accurate. I can use this to explain things. The LLMs, these foundational models, don't have that accuracy, don't have that explainability, don't know my organization. Do we expect these foundational models to know every single organization? No, because these things is private. I don't want them to know, but I want to go use them. So that's why this combination of these foundational models, large language models, with your internal brain of organization, which is your knowledge graph, that's what I see where there's a future. And I think what we need to work on is understanding best that integration point between the knowledge graph, the brain of your organization, and these foundational models. The naive one is a prompt engineering, right? Use some RAG architecture. We're going to expand this. This is what's going to happen, what we're going to be working on in the next couple of years to figure out what that integration is. And then it's going to be a plug and play. You're going to have all these foundational models saying, no, I can work with your knowledge graph. I can work with your brain, right? Just plug and play, plug in your brain here and boom, you're powering up, right? And then also, I don't want to be, as my company, I've invested so much in my brain. I don't want to get tied just to one, but I can probably move around. I mean, it's just like, it's going to get like another cloud, right? But you maybe could get all bought in, right? We use everything we're an AWS shop, right? We're an Azure shop. I do everything there. I mean, that's probably where they go, but people are still multi-cloud, right? So I want to work with different foundational models. So then that's going to happen. So we're going to have these integration points. So I do think that organizations are going to be investing in creating their brain, which is their knowledge graph. You have all these foundational models, and then it's just going to, we're just find better ways of plugging and playing, and that's how that's the integration points that are going to happen, and that's what we're focusing on. That's how I think about it. I don't know. What do you think?
This is like a project that I'm, maybe starting to embark on, is kind of a taxonomy of weaknesses of the current systems. And I do think you're hitting on a big one there that I think that ultimately kind of boils down to the fact that, in today's systems, there are the weights, the model itself, and then there's like the stuff that you're putting into it at runtime. And that is, the input, the context, the prompt, but it's limited and there's nothing between those two. I've been really obsessed recently with state space models as something that may enable a much longer and perhaps more coherent, perhaps more agentic, perhaps more human-like, although I don't, I would heavily caveat the human-like because I always try to remember too that these things are pretty alien in critical ways. You can fine-tune a transformer model for behavior, but you end up kind of narrowing that behavior typically, and you lose a lot of the generality when you do that. So you're kind of dialing it into a specific task. That's to my finding, usually with the fine-tuning that I've done so far. You can't really do something where you're like training a transformer model like you onboard a new employee. And so I'm looking for something where I want to be able to give a AI system like a big body of knowledge and say, and maybe like a bunch of history and like, here's a bunch of things that we've tried in the past that have, worked and some that have failed. And I kind of want to download that knowledge into a system, not necessarily update the weights, but have that encoded in some way where it can be then used to inform, the runtime tasks that I want to give it. And I think state space models are shaping up to be a good solution there.
If I abstract what you just said, is like you're giving your body of knowledge, things that that works, that it doesn't work right now. How are you representing that? Well, text or whatever. I think all these things should be structured right in the graph, in the knowledge graph. But you're giving your knowledge, something you have, and you're going to pass that on to these other foundation models. And you're saying, hey, let's go do something together, right? So there's like, that's the thing. Is like you have this foundational models, you have your knowledge, you want to be able to integrate, combine that. And again, how are we going to go do that? What are those integration points going to be? That's what we're going to go find out. What is even the best one? What does even the best mean? I don't know. Well, we're figuring this out. And then you'll be able to go combine that. And that's how you're going to deal with the privacy issues. Like you're not right. So that's what I find really exciting. Is like you're combining external and internal things together. And that's what's going to make it super powerful.
You've said a couple of times along the way, the no BS take on it. And I know that that's a theme of your own podcast. You want to tell us where people can hear more from you if they want to go deeper down the data rabbit hole with you?
Yeah. So I in addition to the other kind of side work I do at Data.world is together with my co-host, Tim Gasper, who's our Chief Customer Officer. We host Catalog and Cocktails, the honest, no BS, non-sales and data podcast. We've been at it for, I think we're on our 4th year now. So we started season 7. I don't know, I've lost thinking like episode 160 or something like that. We talk about all things enterprise data management, analytics, governance, all this stuff. So honest, no BS, because life is too short for BS and drama. So
cool. I love it. Well, I'll check that out. I'm sure others will too. For now, Juan Sequeda, Principal Scientist, Head of the AI Lab at Data.world. Thank you for being part of the cognitive revolution. It is both energizing and enlightening to hear why people listen and learn what they value about the show. So please don't hesitate to reach out via email at tcr@turpentine.co, or you can DM me on the social media platform of your choice.
Omneky uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omneky so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.